Hello, everyone. I am Megan Keys, National Account Manager for the Commercial Channel at Johns Manville. Thank you for joining us today. A few housekeeping notes. Should you have questions during the presentation, use the chat box on the right-hand column of the webinar dashboard. We'll address all questions at the end of the presentation. A recording of this webinar will be available online, and we will send out an email once it has gone live. Finally, please ensure that your computer speakers are turned on and the volume up or have headphones available, as we will play a video that we'd like for you to be able to hear. So let's get started with our presentation. Joining me today is Michaela Roy. Michaela is responsible for day-to-day technical assistance on all JM building insulation products. She also assists with technical inquiries for the Performance Materials Group and for IIG. Additionally, Michaela helps create and update technical bulletins, installation guides, as well as other forms of technical documentation. She holds a Bachelor's of Science in Chemical Engineering from the University of Colorado at Boulder. She enjoys tackling any issue and providing our customers with solid, research-based solutions in a timely manner. Today's training will cover mineral wool insulation and its growing use in commercial construction, what it is, what it does, how it works, and where it's used in building construction for thermal and sound control. We will also review Johns Manville's complete mineral wool offering, including our new exterior product, Cladstone Water and Fire Block, and most excitingly, we will discuss the design, performance, and efficiency improvements to our SAFB mineral wool insulation. I will now pass the mic to Michaela to review the use of mineral wool in commercial construction.
Thanks, Megan. Hello, everyone. Thank you for allowing me to review our mineral wool line with you today. So, what is mineral wool? Here's a summary of the main characteristics that define its physical properties. It is made of inorganic fibers derived from basalt, a volcanic rock. It is inherently non-combustible. At a melting temperature that exceeds 2,000 degrees Fahrenheit, it will not burn or release harmful smoke. With a thermal resistance value of approximately R4 per inch, it improves thermal performance by reducing the transfer of colder heat through the building structure. Mineral wool also offers good sound attenuation properties by blocking and absorbing sound as it moves through walls and floor ceiling assemblies. Mineral wool is water resistant, so it will not absorb water or degrade if left exposed to water, and is air and vapor permeable. Now that we have a better idea of what mineral wool is, let's take a quick look at how it's made. The manufacturing process for mineral wool is very similar to fiberglass. In JM's case, basalt rock is melted and spun into fibers. These fibers are then layered and bound together into different thicknesses and densities. From there, the material is cut to size and compression packed. JM's products are unique in that they are manufactured with 100% basalt rock as the base raw material, which leads to a cleaner and lighter product that is easier to manipulate in the field. The competition uses about 70 to 90% metal slag as a base material in their manufacturing process. Slag is a byproduct of the steel industry and is comprised of spent iron ore and limestone and makes the product heavier. When looking at commercial construction, mineral wool can provide a number of solutions. This graphic identifies the most common and widely accepted applications. Each product is designed with specific performance properties in mind, depending on where it is used within a building. Mineral wool can be used in the cavity of exterior walls to improve thermal performance, in curtain wall systems to enhance perimeter fire containment, in interior partition walls for sound and fire control, and can be used on the exterior of a building as continuous insulation. JM now offers a product for this application, JM Cladstone Water and Fire Block, which we will discuss in more detail as you move through today's presentation. Now let's discuss the need for continuous insulation. When considering the use of continuous insulation on the exterior of a building, it is important to understand the purpose as well as the relevant performance requirements. The purpose of exterior insulation is to combat thermal bridging. A thermal bridge is an element in a building assembly with relatively higher thermal conductivity than the surrounding materials, which allows heat to bypass thermal insulation. These diagrams happen to show wood framing, but the concept is the same for metal. The physical connection through the assembly allows heat to transfer much faster at the studs. This effect essentially short-circuits the beneficial properties of cavity insulation as heat is conducted around it through the framing members. Even though we install a certain R value in our wall cavity, the reality is the entire wall does not contain cavity insulation, and different sections of a wall will perform differently. When considering all of the framing elements around doors, windows, and other openings, the diagram on the right illustrates how the amount of framing can easily account for 25% or more of the total wall surface. With this in mind, let's look at the thermal performance of some common building materials. Wood, concrete, and steel all form thermal bridges because they all conduct heat. When compared to batt insulation, wood is about 3.5 times more conductive, concrete is about 35 times more conductive, and steel is about 1,400 times more conductive than batt insulation. As you can see, steel is extremely detrimental to the thermal performance of a wall. Now, let's take this one step further and look at how thermal performance plays out in an actual assembly. Here, we have an example of a basic wall section. We're showing two sections through this wall. One where a framing member is, which is shown in the column on the left, and one through a cavity, shown on the right. The numbers in this table are R values, except for the U value calculation towards the bottom. Notice this assembly has no continuous insulation. The total R value of the wall at the framing section is only R3.2. The steel provides almost no R value, only about R0.69. Looking at the cavity section, we're showing R13 batt insulation in the cavity, which gives us a total R value of R15.5 at this location. These two values can be combined to achieve the total effective R value of the assembly. This is done by first converting to the U value and then back to the R value for the entire wall. As you can see at the bottom, the effective R value is only R8.1, despite the fact we used R13 insulation in the cavity. This example demonstrates the impact of thermal bridging and the need for continuous insulation. Here's a larger image of the one we just looked at. An infrared camera allows us to see how the studs are, in effect, obstructing the thermal performance of the cavity insulation. In contrast, the image on the right shows the same structure with the addition of continuous insulation. This demonstrates a much more efficient envelope, which is the ideal energy performance codes are trying to achieve. The addition of continuous insulation to the assembly has not only increased the R value, but the impact of thermal bridging has been significantly reduced. This is what gives us a combined benefit of greater than an R4. This example provides a clear reason why we're seeing an increase of this application in all construction types. Every state has adopted their own energy code requirements. Your territory manager and the JM technical team can be a great resource for the codes in your local area. Now that we've established the benefits of continuous insulation, let's discuss the types of materials that are typically used to help fulfill this continuous insulation requirement and achieve the desired and specified R values. Various forms of continuous insulation are available from Johns Manville: rigid polyisocyanurate foam board, mineral wool, and closed cell spray foam. While foam plastics provide a number of benefits when used as continuous insulation to block thermal bridging, the use of mineral wool in building design for this function is increasing, especially for high-rise buildings that take longer for people to evacuate. Exterior rigid foam insulation can become a fuel source in a fire situation. Photos here of the Address Hotel in Dubai and this apartment building in Dijon, France, illustrate the possible fire risk. While many rigid foam products carry a Class A fire rating, they can still burn, and we are seeing building codes mandate specific construction requirements that call for either a completely non-combustible structure or non-combustible exterior walls with combustible interior framing. It is important to note that foam plastics are an essential part of commercial construction and are available from JM. Foam plastics are able to provide thermal benefits as well as air and moisture control benefits. This is by no means trying to deter you from using foam products as continuous insulation. Rather, we are focusing the conversation today around mineral wool and why a designer may opt to specify it in some circumstances. You may have heard about NFPA 285 testing. So, if we're thinking of using continuous insulation in types 1 through 4 construction, how is it we can use combustible foam plastics in a building type that calls for non-combustible materials? Well, we can, as long as the product meets additional testing requirements. specifically NFPA 285 assembly testing. NFPA 285 is required on all type 1 through 4 buildings greater than 1 story when combustible materials are used in the exterior walls. This diagram shows the typical trigger points and related code sections where combustible components are often introduced into a wall system. So, if my wall system requires NFPA 285 testing, what does that really mean? The test itself measures flame propagation via exterior wall assemblies and requires a mock-up of the actual wall being used on the project. It simulates a fire room and measures flame spread from floor to floor over a 35-minute period. If the flames are contained within a specified area, the assembly passes. Getting an assembly approved is a complex, slow, and expensive process. Tests typically range between $20,000 and $50,000 and require the coordination of design professionals, contractors, and manufacturers. The burden of testing often falls on the manufacturers, and no two manufacturers test the same components. Therefore, the amount of approvals can vary greatly between products. This scenario has created a body of test data that is inadequate and confusing to navigate. Well, what if I told you there's a simple solution to this problem? Because mineral wool is non-combustible, it eliminates the need for NFPA 285 testing altogether. So now, let's explore more about mineral wool as both an interior and exterior solution to thermal bridging, as a rain screen, and for use for sound absorption. Mineral wool has the best fire performance of any insulation material on the market, with a melting point well above even fiberglass, and carries a flame and smoke developed rating of near 0. Let's watch a video showing some of the aspects of mineral wool that we have discussed so far, and introduce the enhancements made to our mineral wool line that make the product easier to handle and install, and prevent it from slouching in the wall cavity.
Building scientist at Johns Manville. In this video, we will demonstrate how Johns Manville mineral wool insulation delivers consistent thermal insulating performance, helping to keep buildings and homes quieter, safer, and more comfortable. Johns Manville mineral wool insulation is made of rock fibers derived from basalt, a volcanic rock, as well as lime and dolomite. Advanced manufacturing technology ensures consistent and excellent product quality for JM's broad line of mineral wool products, ensuring that our customers have the best possible product to stay safe and comfortable. Because Johns Manville mineral wool insulation is made from natural rock, it is non-combustible and can withstand temperatures in excess of 2,000 degrees Fahrenheit or 1,093 degrees Celsius and not melt. JM mineral wool will not burn and can act as a barrier to fire and slow the spread of flames. This is demonstrated by exposing JM mineral wool insulation directly to a large flame. The insulation in this cavity has been installed over a piece of OSB sheathing. You can see the insulation will glow red but will not melt or catch fire. In addition, the OSB has been protected from the fire, and infrared imaging used at the backside of the insulation demonstrates a cooler, consistent temperature despite the use of a large flame. When the insulation is removed from the cavity, you can now see how quickly the wood catches on fire. Clearly, the JM mineral wool was providing significant fire protection to this naturally flammable wood material. JM's mineral wool insulation is designed to provide superior fire resistance and thermal properties and can be used in fire-rated wall assemblies as required by the building code. In addition to being fire resistant, Johns Manville mineral wool also repels water. This demonstration shows Johns Manville mineral wool insulation being sprayed with water from a hose. We can now see JM mineral wool in action. Look at how the water runs off, the insulation remains intact and does not slump, all while the interior remains dry and unaffected. As a result, the R value of the insulation is also not affected. This example is far more extreme than anything our product would be exposed to in a real-world application, but it demonstrates how well JM mineral wool repels moisture. Because JM mineral wool is made from natural rock fibers, it will not mildew, support the growth of fungi, or corrode. Unlike some other mineral wool products on the market, Johns Manville mineral wool is easy to cut with a standard insulation knife for quick installation. This allows for a snug fit into any wall cavity and helps eliminate gaps around obstructions in structural members, which helps keep rated R values. Throughout this video, I've been in our anechoic chamber at the Johns Manville Technical Center in Littleton, Colorado. Right beside me is a plexiglass box, insulated with JM mineral wool insulation. Inside the box is a loud emergency alarm. As we lift the lid, we can hear how loud the alarm is. When we replace the lid, you can no longer hear it. This helps you understand just how well Johns Manville mineral wool insulation absorbs sound and efficiently reduces sound transmission. Installing JM mineral wool reduces unwanted noise from traveling from room to room, making buildings and homes quieter and more comfortable. Thank you for letting us showcase how Johns Manville mineral wool insulation helps keep buildings drier, quieter, and safer. The raw materials used to manufacture JM mineral wool insulation naturally make for a non-combustible, moisture-resistant, non-deteriorating product that will not mildew or support corrosion. For more information, please go to jm.com.
Now that we have reviewed the benefits of mineral wool, let's focus on the specific JM products available to meet every need. Sound attenuation fire bats, often referred to as SAFB, Cladstone water and fire block, safing, and a rigid board for curtain wall systems. When it comes to our SAFB line, we heard what you said, so we've made some changes. With improvements made to design, performance, and efficiency, our SAFB mineral wool insulation has been reformulated to stand up against the competition. SAFB is a bat-type product and is used in many of the same applications as fiberglass. It comes in standard sizes that are designed to fit the cavity of typical stud-frame walls and is often used in interior partitions and demising walls to reduce sound transmission. JM Compression packs its 2 and 3-inch SAFB products, which offers a number of advantages. Not only can you get more material on a truck, it takes up less space in the warehouse and fewer bags need to be delivered to the job site. JM SAFB 2.0, robust design and redefined packaging. With improved integrity and rigidity, the product won't slouch once installed. It will bounce back to its full thickness once removed from the packaging, and the more durable packaging helps the product arrive intact. If you have not already seen a sample of our improved SAFB product, please contact your local territory manager to see the difference. Now, let's look at the new exterior solution. JM Cladstone is available now in 4.5 pound and 6 pound densities, 2 and 3 inches in thickness, and in widths of 16 and 24 inches wide, matching the competitor's offering. Along with the other products in our mineral wool portfolio, Cladstone is manufactured in our Phoenix City, Alabama plant and is available to top load with fiberglass bats out of all of the fiberglass manufacturing facilities. The 4.5 pound board seems to be the most common density, but the 6 pound board is typically seen when called out by a specific architectural design that benefits from a board with more density. The R values are essentially the same for both boards. As you saw in the video, Cladstone is engineered to repel and drain moisture. It can handle condensation, driving rain, and other moisture that may be introduced into a wall assembly by preventing water ingress and allowing pressure equalization. Additionally, it provides thermal performance within the drainage cavity and can be used in both permeable and non-permeable assemblies. And as we discussed earlier, it totally eliminates the NFPA 285 testing requirement. Cladstone has an R value of R 4.3 per inch. By comparison, rigid foam products have an R value around 6 per inch. For a continuous insulation application that calls for an R10, 2 inches of rigid foam or 2.5 inches of mineral wool would meet this requirement. So we aren't talking about significantly thicker wall systems when using mineral wool. Cladstone is a semi-rigid product that is easily cut, and is flexible enough to conform to radius facades and construction irregularities. It comes in standard sizes and is designed to work with common cladding and Z-girt hanger systems. Or it can be installed with abutted joints and mechanically attached to the building substrate. Note, the joints do not need to be taped, as this product is not acting as an air or vapor barrier. Rain screen and cavity wall systems vary greatly from types of hangers to how they are installed. The need for, and proper placement of, air and vapor barriers and moisture control layers must be determined by a qualified professional engineer or architect. Considerations include the interior and exterior climate and air pressure conditions of the building. Another mineral wool board product available from JM is curtain wall, which is specifically designed for use in curtain wall systems and comes in different thicknesses and densities. It is typically installed at the job site or in panels that are prefabricated off-site. JM's mineral wool curtain wall is available unfaced or with an SSP scrim reinforced foil facer on one side. As a complementary product, safing is commonly used in conjunction with curtain wall systems to fill the space between the spandrel panel and slab edge along the perimeter of each floor. This is done to stop fire from traveling between floors along the exterior wall of commercial high-rise buildings. The diagram on the right illustrates a typical safing application. You can see the material is placed in the gap between the floor slab and the curtain wall. Code often requires this space must be filled with a non-combustible material to maintain fire ratings between floors. Lastly, JM does offer mineral wool products for residential as well. Our temp control and sound and fire block products can be used as an alternative to fiberglass bats to improve the thermal and sound performance of residential structures. Well, that's the JM offering. Listed above are the names of JM mineral wool products and their competitive product name for your reference. For assistance with switching specifications from a competitive product to one that JM offers, please work with your territory manager or JM Technical Services. This is a service that we are happy to provide in a timely and efficient manner. When it comes to installing the new JM SAFB, we have made improvements to allow for efficient and fast installation on the job. The enhanced integrity of the bat keeps it from tearing when pulled or handled, and it can be easily cut with a standard installation knife. Additionally, the product packaging has been upgraded to get the material to you and to your job site intact. JM continues to offer the advantage of mixed truckloads, allowing you to order only the amount of products that you need, improving inventory turns, reducing space in your warehouse, and on the job site. We are here to help. Contact one of our JM technical experts at 1-800-654-3103 for information about equivalent products, physical product properties, lead compliance, or any other technical performance details. Call your territory sales manager for information regarding specification or substitution requests. I personally answer these types of inquiries daily and take pride in assisting JM customers with their technical questions and needs. In summary, mineral wool is a versatile and durable material that has a wide range of applications, both interior and exterior. It is inherently non-combustible and provides better acoustic performance than rigid foam. JM SAFB improved formulation stands up to the competition, giving your customers more options for their projects. Your customers can get a combination of JM insulation products, fiberglass, mineral wool, rigid foam board, spray foam, and tile backer board, all on one truck. More product per bag means more product per truckload, resulting in freight and storage savings. If you or your customers have any questions about the product, lead compliance, or any technical performance details, our JM technical service experts are ready to help. Thank you for your attention. I will now open up for questions.
Thank you for everyone who sent in questions. Michaela, the first question is, what is the difference between curtain wall and cladstone?
Thanks, Megan. So the difference between curtain wall and cladstone comes with application. JM has designed cladstone to be used outside of the building envelope and has been formulated to resist and repel moisture, allowing it to bead up and fall off. Curtain wall is intended more within the building envelope where it can be protected by moisture and air barriers.
Okay, and also related to cladstone, does your product meet your competitor spec requirements?
Okay, so cladstone has been tested to all the same standards that our competitors have tested to and either meet or exceed their standards.
What is the process to have JM products switched on a competitive spec?
So to get our JM products on a competitive spec, please let your territory manager know about the job, and he or she will work with me, and I will work with the architect or GC if necessary to get the JM products approved.
Okay, and I think the last question is more for me. Are mixed truckloads available from all fiberglass plants? The answer is yes, mixed truckloads are available from all of our fiberglass plants. Please work with your local territory manager to find out the availability of product in your specific area. That concludes our presentation today. Thank you for the questions, and please join us for our next webinar on Wednesday, February 7th at noon Eastern, where Dodge Analytics will be presenting and will review 2017 industry data, challenges facing the construction industry, and will share their outlook for our industry for 2018 as well. Thank you again. Everybody have a great rest of your week.